This question belongs to algorithm subject and was asked in GATE 1991, and the topic name is sorting. So the question states the minimum number of comparisons, the minimum number required to sort 5 elements is. So suppose we have 5 elements. Let us suppose A1, A2, A3, A4 and A5. Here we are not being asked about the best case, as best case would be insertion sort, and for n items n minus 1 comparisons, as it would we will assume a sorted array. But here we need to take a general case. So let us suppose we have 5 items. So what are the ways of arranging these 5 items? We can have n factorial ways to arrange n items. So we will have 5 factorial ways to arrange these 5 items. So how will they look like? They will look A1, A2, A3, A4, A5, followed by A1, A2, A3, A5, A4, and so on like this. There would be some items, and then there would be some items in which A2 will come before A1, A2, A1. Here all A1 will be before A2. Then we will have some items A4, A5, A3, A5, A4, and there would be so 5 factorial is 120. So as these are half half, so we will have 60 items like this and 60 items like this. So what happens in comparison based sorting? So we are basically comparing two items. So let us suppose we are comparing A1 and A2. Now there can be two cases. Either A1 is greater than A2 or A1 is less than A2. If A1 is less than A2, then we can discard this part, as out of these n factorial combinations, out of this 120 combination, only one combination will be our sorted answer. So we can discard this part if A1 is less than A2, as we can't have A2 before A1. And if A1 is greater than A2, then we can discard this part. So let us suppose we are discarding A1 is less than A2, so we are discarding second part. Now also over here, half of the items, now let us suppose we are making second comparison between A2 and A3. So out of the 60, 30 will have A2 before A3 and 30 will have A2 after A3. Let us suppose A2 is greater than A3, so we can discard this part. Which means at each one comparison, we are discards half possibilities. This is very important thing. As one comparison discarded 60 possibility, then another comparison discarded another 30 possibility, then another comparison will discard another 15 possibility, and so on. It will continue till we will reduce this n factorial possibilities to one possibility dividing by 2. So if we have n items and we reduce n items to 2 items, n items to 1 items by dividing by 2, then the number of steps equals to log n base 2. So here in this case, number of steps would be log n factorial base 2. And these are comparisons, so we will have an upper bound. So our answer is log n factorial upper bound base 2. So what is the value of n? N is 5. So log base 2 5 factorial upper bound. So we have log base to 120. What is 2 to the power 6? It's 64. What's 2 to the power 7? It's 128. So it would be something like 6.x upper bound. Sorry. What's 5 factorial? 5 factorial is 5 into 4 into 3 into 2 into 1. 20, 3 is 60, 62, 120. Now let us see. What is 2 power 6? It's 2 to the 4 to the 8, 16, 24, 32. What's 2 to the power 7? It's 64. What's 2 to the power 8? It's 128. So we can easily see it would be 6.x upper bound. So we can write it 7. So we need 7 comparisons, minimum comparison to sort 5 items. So answer is 7.